Welcome to this video about logistic regression. Logistic regression is, despite its name, it's a popular algorithm for classification. It's kind of, if you have this basic machine learning tutorials like this one, then you have two algorithms with which basically every tutorial starts. The first is linear regression and the second is logistic regression. And if you have understood linear regression, then the step or understanding logistic regression becomes much more easy. And so they are kind of they are similar to each other, but also they are very different. The first one, linear regression, is a regression algorithm, so you predict some continuous variable, while in logistic regression you predict a class basically. So you predict a categorical output variable. Okay, so what are the basics? And basically, logistic regression. Maybe we start with a linear regression example, so that you understand what happens here exactly. Okay, so first of all, we have two-dimensional, for example, two-dimensional data. We have the x data, the x-axis, and the y-axis, and the x-axis might be some days, for example. So we have different upcoming days, and the y-axis might be a stock price, for example. Yeah? And now we want to predict the stock price on different days. And let's say we have we have collected some data points here. These are our training data points. And basically now in logistic regression, so the stock price is a continuous variable. So we want to predict the stock price, and this can be 122.417, or it can be 100 or 1.3148. So the stock price basically can be any real value. So we have this continuous variable which we want to predict. So we have a continuous input variable and a continuous output variable. Yeah. And now in linear regression we learn this line, and the line is used to predict any continuous input value. So it maps continuous input value to continuous output value. Okay, but logistic regression is different, because for example, it is used for different kind of problems. Yeah. So again, we have this. Say we have this two-dimensional. Okay, let's have a bit more space here. Okay, now we have this two-dimensional space here, and we want to predict the probability of. So we have this classification problem. Yeah. So we have two outcomes. The first outcome is lung cancer. Maybe that's cancer, and the second outcome is no cancer, so it is basically healthy. Yeah, so we have these two classes, whether you have cancer or whether you have not cancer, and the x-axis is still a continuous variable. For example, it could be the number of cigarettes you smoke per day, for example. And the more cigarettes you smoke, the higher the likelihood that you will develop cancer during your lifetime. Okay, so this is a type of problems addressed by logistic regression. So we have the continuous input variable, similar to the linear regression example, and we have the categorical output data which we want to predict. And basically, the logistic regression does not only give us predict the class, but also the probability of the class. So it gives us also an estimate how confident our machine learning model is that certain number of input maps to the respective class. So we have, for example, now in this case we get something like this. We have our input, which is the number of cigarettes. We have the machine learning model, and the machine learning model gives us like a probability 89% no cancer and 2% cancer. Yeah, something like this. This is our output, so that we are we also have the confidence. Maybe you have 0, or maybe put in 10 cigarettes and get out this one. Yeah, if you have only smoked 10 cigarettes, and then you have high probability of having not cancer. Okay, so now we have some observations. Yeah, so we want to train this model, and basically we are now, let's say we have observed many people here. They have smoked different number of cigarettes, and all of them have do not have cancer. Yeah, and some people have smoked a lot of cigarettes, and they still have no cancer. Yeah, so we have something like this. But then there are also people who have smoked a lot of cigarettes during their lifetime, and they have developed cancer. And also some people who have not smoked cigarettes and still develop cancer. Yeah, so we have kind of this distribution. And now, basically, the logistic regression, in a linear regression case, we fit a line through the data. But in this case, it doesn't make sense to fit a line through the data, right? So it basically, in logistic regression, it treats the y-axis as the probability of developing of a certain class, yeah, of developing cancer, for example. And now it fits an S-shaped curve. I tried to draw it like this, yeah. So an S-shaped curve. You can see it resembles the shape of an S through the data. And the S-shaped curve is called sigmoid function. And of course, you have some parameters like the slope of the curve, and you can move the curve to the right and move it to the left. And yeah, try to find the curve that fits the data, that minimizes the error or maximizes the probability that the data arises. Yeah. And okay, and then suppose we found the curve. Basically, the algorithm, I can explain you the algorithm in a moment, but yeah, say we have found the curve that fits the training data. Now we simply use for example, if you smoked 4 cigarettes, then you just check the y value of the curve, and it gives you the probability that you develop cancer, like here maybe 30%. If you smoke more cigarettes, then your probability will be, I don't know, like 80%, for example. Yeah. So the S curve, basically, it gives you an indication. It gives you the probability for a certain class. Yeah. And the good thing is that this is kind of in the two-dimensional space. This is like a decision boundary. It tells you if the probability is higher than 50%. You would estimate that you are in the upper class. If the probability is smaller than 50%, your guess is that your input data lies in the lower class, so to say. Yeah, and okay, and basically the algorithm is simple algorithm. Okay. So how do we find? How do we find the S-shaped curve? Again, I draw another input box, and now we have some data here. We have two classes again, some data here, and now basically what it does is it starts with any S-shaped curve. Yeah. So let's draw it in another color, like red. Maybe we start with this S-shaped curve. Yeah. And now we calculate the likelihood for a single training data. Yeah, so for example, we take this training data, and now we check how likely it is that given this S-shaped curve, this training data lies in this class. Yeah, and you can see, the likelihood is very high. Yeah, so we have, for example, here 99%. This curve predicts that this training data is 99% correctly placed. Yeah. So basically, it's okay, and it repeats this for any training data, for all the training data. Like for example, this one, you would check. Okay, the sigmoid curve predicts that the likelihood is 50%. but indeed it knows that the probability of this training data being in the class is 100% because we have observed this. Yeah. So it basically then, in this case, the error would be 50%. Yeah. In this case, the error would be 1%. Yeah. And now we repeat this procedure for all the training data which we have. We sum up the error, and this is more or less approximately, and this is called the maximum likelihood. Yeah. So we calculate the maximum likelihood for the sigmoid function, and then we move the sigmoid function a bit. For example, we move it to the left. And now we draw the sigmoid function and we try to describe it, and we calculate this. So this first gives us one value. I just use the sum sign. One value, this is our likelihood for the first sigmoid function. Yeah. And now again we calculate this maximum likelihood for this sigmoid curve. Yeah. And then we check, is this maximum likely? Is it more likely that this sigmoid function describes the data than this sigmoid function? If so, then we take this sigmoid function as the next step, and then we move this sigmoid function to the right. And we repeat this procedure until we have found the sigmoid function that generates the highest probability of the training data. So we want to basically find the sigmoid function that describes best the training data. Okay. This is a general idea of training the algorithm using the sigmoid function. And yeah, now let's dive into the code. So I first open the code window. Okay, and move it up. So okay, let's dive into the code. So first we import the sklearn library, the linear model module. Yeah, and we import logistic regression. And we also import NumPy. As always, we import NumPy. And now let's first create the data. So we use this previous example. Yeah, so we create a NumPy array. We have number of cigarettes and the class. Like if he smoked 0 cigarettes, he didn't develop cancer. He smoked 10 cigarettes and he didn't develop cancer, for example. And smoked I don't know, 60 cigarettes and it did develop cancer, and smoked 90 cigarettes and did develop cancer as well. Okay, so this would be a kind of a health app or health prediction app. Can be a small app. Do you develop cancer? Check your probability, for example. Of course, you would need some real training data. Okay, so now let's create a model. First, we use the constructor logistic regression with no parameters as a default option. I would always try to keep it simple initially and then improve upon this one. Yeah? It's really often you see people are doing pre-major optimizations, so they try to prevent inefficiency. They try to optimize the code even without necessity. So this is, I think, maybe one of the most common mistakes of beginner coders, that they try to optimize everything, that they produce really cluttered code. But I think pro coders always try to find the simplest way of solving a problem. And this one, first we check the simplest way. Does it solve our problem? If so, then there's no need to look further. Okay, so now let's take the first column as the input and the second column as the output. Yeah. Okay. And there's one caveat. If you would execute this code, it would throw an error. I will show you. yeah, the reason is here, reshape your data either using array reshape if your data has a single feature, or blah, 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 if it contains a single sample. So our data, I just copy this. Our data, now the problem here is we use slicing to access the first row, which generates a one-dimensional array as input and a one-dimensional array as output. But the expected input is a two-dimensional array with one row per training data or observation and one column per feature. And even if you have a single feature, it expects you to generate an array with this form, like I just write the array now, something like this, 10, 60. I just write it once because this is required for all machine learning algorithms which we will look at. It's important that you see that your input data should always be two-dimensional at least. It doesn't make sense for the scikit-learn library to use one-dimensional input data because it expects one row per training data and one column per feature. Yeah. So, and therefore, if we would skip these brackets, then it would not be able to process the data. Okay. Therefore, we use this reshape operation. So you already know the shape. And we the shape operation from previous tutorials. If not, then have a look at some basic NumPy functions. It's really important. I am also in the process of writing a NumPy book, so check it out. And yeah, this is really important that you understand the basics of NumPy. If you use any machine learning, you see we are using another machine learning library like the scikit-learn library, but we are relying on NumPy to access the functionality. This is not even possible with pandas. Many people in data science ask me, "Yeah, what about pandas? Why don't you start with teaching pandas?" Because it's some find it more, some find it easier to start with. But I'm a real big proponent of starting with NumPy because NumPy is even the basis of pandas. So pandas builds upon NumPy, but NumPy does not build upon pandas. NumPy is kind of the most basic data science library you can learn, and you should learn if you want to do anything in the space machine learning and data science. Okay, so yeah, therefore we reshape our array from the one-dimensional array to a two-dimensional array. So we have two dimensions now, and the second dimension is 1, which means that we have one column. So this is the number of rows, this is the number of columns. We have one column. And this -1 is a dummy operator, which just tells NumPy that, yeah, I only want to have a two-dimensional array with one column. Just fill the number of rows automatically, because it already this array has already 4 items in the array, and we want one row, so it can calculate how many columns. We need one column, and so it can calculate how many rows it will take. Yeah, so it does this for you automatically. Okay, now we have created the model, and now there's only one thing left, which is printing the prediction. Yeah, now we predict for, let's say we predict for different again we have a two-dimensional input. Each NumPy, each array here, basically each one element array here is an input for which we calculate an output in the process. Yeah. Okay, so now let's, for example, here we smoke 2 cigarettes. What's our probability? We smoke 12 cigarettes. What's our probability of developing cancer? We smoke 13, and let's try 40 and 90. So we try different combinations here. And yeah, now we check the output. So first of all, before I run this code, what would you expect to happen here? Think about this for a moment. A person smoking 2 cigarettes, will he develop cancer based on our data? No. With 12 cigarettes, most likely not. With 13, most likely not. With 40, maybe. With 90, sure, it should develop cancer based on our data. Okay, so let's execute this. again, just re-execute. Okay, and as you can see, we were almost correct. We predicted no, 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 yes, yes. And yeah, but basically then you can see that between 12 and 13, your S shape would generate a probability that is higher than 50%. So, of course, I mean, based on the training data, he could not know. Basically, he just moved the S shape as close as possible to the 10, to the value 10. I can show you here in the. I can show you here. Okay, so again, we have this box, and we have our S shape, we have our data, and now we have only very limited data, like here, 2 data points here, and then 2 data points here, far on the right. And now, of course, many S shapes generate high likelihoods, basically. So, for example, this S shape would describe the data very nicely, yeah? Maybe with the 50%, 50% being at, I don't know, 30 cigarettes. But also, this S shape, no, it's a bit ugly. This S shape is also fine because because now the probability of those two is still very low. The probability of those two persons developing cancer and the probability of those two persons developing cancer is very high. So this curve fits as well, and every curve in between fits as well. So the problem here is that we have too little data. Basically, there are too many degrees of freedom for our sigmoid function, and therefore it just finds any. And you see, this function is not intuitively perfect, but if we had more or better data, then it would produce better result as well. Okay, but you can immediately use logistic regression for classification if you have 2 classes. If you have more classes, then it's not directly applicable conceptually. Yeah, but you will learn about many more classification algorithms in the following. But logistic regression is one that you most likely need to know in order to get the basic understanding of classification problems, and also have the opportunity to get this probability value. Like here, it always gives you this probability value of lying in a class, and this is one specialty of logistic regression in comparison to other classification algorithms that won't give you this probability. They will just tell you, oh, this in this class, but I don't tell you how confident I am that your input is in a certain class. Okay, thanks for listening, and see you in the next video.